So we're going to look at 3 sections, and we're going to start by looking at 5.3 and 5.5. And I'm going to review a theorem that we learned earlier in the year, and we're going to take this theorem and make an inequality. So for today, just think this. Almost everything I teach you has to do with an inequality. And so if you think about the inequality signs from Algebra 1, greater than, less than, greater than or equal to, less than or equal to, or does not equal, these are called inequalities, and these theorems all have to do with inequalities. So it's kind of weird. You don't have a lot of those in geometry, except for these sections. Okay, so this is the old theorem that we learned earlier in the year, the exterior angle theorem. So according to the exterior angle theorem, the measure of angle 1 is going to be equal to the sum of the remote interior angles. So you might remember this when we talked about it. If you add up the remote interior angles, they equal the exterior angle. So this would be the measure of angle 2 plus the measure of angle 3. So that should seem familiar to you. We've already learned that theorem. And now we're going to take that and use it to make an exterior angle inequality theorem. So according to this, if I have angle 1 and it's equal to the sum of 2 and 3, then 1 would have to be greater than 2, and 1 would have to be greater than 3. So that makes sense because if 1 is equal to the sum of 2 and 3, then 1 has to be bigger than each of them individually. So that's all this is saying. So this is called an exterior angle inequality theorem. So we're going to fill that out. The measure of an exterior angle, which is angle 1, is going to be greater than the measure of either of its corresponding remote interior angles. So it's very easy to understand. If you have an exterior angle, it's bigger than either of the remote interior angles. So that's an inequality theorem. Okay? So that's the only thing we're doing with that one. Now, I numbered this 2. I should have put 2 in here. This is going to be another inequality theorem that has to do with greater thans and less thans. So it's going to have you measure a few things, but I've already pre-measured them for you, so I'll help you out on this. So it says measure angle X and measure angle Z. Okay, so for angle X right here, I got a 40 degrees. So we're just going to insert that into the picture. And for angle Z, I got a 68 degrees when I measured it. So this one says 40 and this one says 68. Now, what we're going to do is we are going to use that idea to compare the sides that are opposite from those angles. So if you look across from the 40, you see a 7, right? And if you look across from the 68, you see a 9. So it makes sense that the sides that are opposite the angles, the side will be bigger if it's opposite from a bigger angle. That's kind of the way it works when you open a hinge of a door. Like if you want the door wider, then what you do is you make the angle opposite bigger. So that's going to be this theorem right here. So we're going to fill this in, and then we're going to look at the converse of it. So it says if one side of a triangle is let's say longer. If one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. And this is not going to be complicated at all. If your side is bigger, the angle opposite will be larger than if your side is smaller, the angle opposite will be smaller. Okay? So this is the same theorem. It's just going to go in reverse. Not really the converse, but kind of the opposite. It works in the opposite direction. So notice that this angle is 110, and notice this is 45. So I'm going to tell you that one of these measures is 4 centimeters. That's going to be this one. That's across from the 110. And then across from the 45 is going to be a 3 centimeters. So this is the opposite of the theorem that we just did. What it's going to say is if you have an angle that is bigger than another angle, then the side opposite the bigger angle is longer than the side opposite the smaller angle. So we're going to fill that in. If one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. So this picture goes with this one, and this picture goes with this one. And it's very easy to use these. Okay, so we're going to use this to practice. And you guys are going to think this is pretty easy. So go down to the bottom. I'm going to show you 2 examples. So for the first example, it says, list the angles and sides in order from smallest to largest. Okay, so I'm not going to list the sides in order. because it's very obvious which side is bigger than which one. So I'm just going to practice on listing the angles. And we want them from, here's what you have to make sure you read, smallest to largest. Okay, so where is the smallest side? 3.7. Across from that, or opposite, will be the smallest angle. So I'm going to say angle B, comma, find the next biggest side. So the next biggest side is 4.8. Go opposite from that. Angle C is the next biggest angle. And then the largest side is 7, so you go opposite that. The largest angle will be A. So smallest to largest goes angle B, C, A. Very easy. You're just using the sides to help you get the angles. Okay, now for number 3, we're going to do the opposite. We're going to list the angles. We're going to list the sides in order. I'm not going to worry about doing the angles because it's going to be obvious. We're just going to focus on the sides from smallest to largest. Okay, now this one has a little twist in it because we really don't know how big this angle is here, but we can find it. So if you subtract these from 180, or just subtract that one from 90 because these are complementary, you're going to end up getting 39 degrees, and that's going to help you now rank the sides. Okay, so let's read again. Does it want largest to smallest or smallest to largest? Okay, smallest to largest. Make sure you put the smallest on the left or you'll get it wrong because you'll have it backwards. All right, the smallest angle is 39, so go opposite that in the triangle. That means the smallest side is segment WY, comma. The next biggest angle is 51. Go opposite that. The next biggest side will be YX, segment YX, or again, you could say XY. And then 90 is the largest angle, so go opposite that. The largest side would be WX or XW. These are not hard to do. You just have to make sure you read correctly which way to do it. Okay? All right, so flip your page over. We're going to do one more section in this set of video notes, section 5.5. And in order to do 5.5, I'm going to do a demonstration here. So if you were normally in class with me, we would kind of do this with volunteers, but I'm going to just volunteer myself. All right, so I have 3 spaghetti noodles. You ready? I'm going to take my 3 spaghetti noodles and I'm going to make a triangle, and everybody's going to clap when I get it. Yay! Okay, now, so I have that triangle made with my 3 spaghetti noodles. Now I'm going to take a different 3 set of spaghetti noodles, and I'm going to make a triangle out of these. All right, so I'm going to take this one, and uh-oh, I can't make a triangle, right? Most people think you can make a triangle out of any 3 segments. These will never close, so even if I lower them all the way down, they're not going to close if I lift them up. So the moral of the story is you can't always make a triangle out of any 3 segments. So I want you to look at the problem here. The problem is if I have this long one, my 2 shorter ones are not adding up to be bigger than the longer one, right? Because if I lift the 2 shorter ones, they need to add up to be longer than that longest one, and they don't. When I add them together, they equal less than the longer one. So that's not going to make a triangle. Now, why did the first one make a triangle? Well, because there's my longer one, and when I add my other 2 up, they're longer than the longest one, which means that it will make a triangle. Okay? So now go back to your notes. This is called the triangle inequality theorem. So we're going to say the sum of any 2 sides of a triangle must be greater than the length of the 3rd side. Not just equal, it has to be greater than. Now here, kids ask me all the time, why doesn't it have to be equal? Let me show you. If this is my longest side and I lift these up to connect, they need to add up to be bigger than that side or they won't lift. It's like a drawbridge. When you lift that drawbridge, they won't close. So the 2 small ones have to add up to be greater than the 3rd. Okay, so here are the kind of questions you're going to have. Determine whether or not it's possible to make a triangle with these 3. Okay, so the only 2 you need to check are you need to check to see if the 2 smallest add up to be greater than the 3rd. So here's what you do. Is 15 plus 16 greater than 30 question mark? Well, what do you think? What's 15 and 16 add up to? 31. Is 31 bigger than 30? Yes. So the answer is yes. this will be a triangle, and if they ask you to justify, you're going to say 31 is bigger than 30. Okay, let's try part B. We take the two smallest, we add them up, and we see if they are greater than the longest side to see if it will close. 2 plus 8, is that greater than 11? Question mark. Well, 10 is not greater than 11, so no, this will not make a triangle. So this would be like my failure to make a triangle, because the two little ones, when you lift them up off the 11, aren't going to be able to close to make a triangle. So this is a yes and this is a no. So there's one more question that I'm going to ask you, and that is this question that kind of has this long drawn out example. I'm going to show you how to do this without going through all of this, but this is the example we're going to focus on that kind of goes with that same inequality theorem. So it says, if the measures of two sides of a triangle are 3 and 7, which is the least possible whole number for the third side? Okay, so I'm going to skip down to this picture. So we made a triangle here, and we have a 7 for one side, we have a 3 for another, and we're going to make an X for the third side because we don't know what the third side is. Now, I don't know if X is the biggest or the smallest or the middle side. We don't know. It's just X. So we're going to take and we're going to apply this inequality theorem to all three. So what I want you to do down here in this little section, I want you to number 1, 2, 3. We have to make 3 separate inequalities because we don't know which one is the smallest side or the middle side or the big side. Okay, so I do know that 3 plus x needs to be bigger than 7. I do know that has to be true for this to work, right? Because any two sides of a triangle have to add up to be greater than the third side. Okay, I also know that 7 plus 3 has to add up to be greater than x. And that's because any two sides of a triangle have to add up to be greater than the third. And then for the third one, I know that 7 plus x needs to be greater than 3. Oh, wait, isn't 7 already bigger than 3? So no matter what I add to it, what other side I add to it, isn't this already going to be true? So I'm going to X this one out. I don't need to do anything with that because that one's already true. I know that 7 plus x is already bigger than 3. Okay, now I need to solve these. So I'm going to subtract 3. X is greater than 4. I'm going to add these two together. 10 is greater than x, and then I'm going to flip this around and make it x is less than 10. So this is the range of values that I'm going to put together for my final answer. So my third side, this side right here, has to be smaller than 10 but bigger than 4. So that is called a inequality, a compound inequality, where I know my third side has to be bigger than 4 and smaller than 10. Okay, now let's go up to the picture, or the question up here. It said, which of these would be the least possible number that I could have for my third side? Okay, could my third side be a 3? Is that between 4 and 10? No. Could my third side be 4? No, because it has to be bigger than 4, right? It can't be equal to 4, so that's out. Can my third side be 5? Yes. Can my third side be 10? No, it has to be smaller than 10. So the answer to the question is C. All right, and we're going to do one more. So if you are at home and you want to pause the video and try this one on your own, you can do that, or you can watch me go through it. I'm just going to go through it one more time so you can see how to do this. Okay, so I have 3 sides of a triangle, and I don't know which one's my biggest, or my smallest, or my medium. So I'm going to make 3 inequalities, and I'm going to solve them to figure out what the range of values needs to be. All right, the first one is going to be n plus 9 is greater than 13. I know that has to be true because the theorem says any two sides of a triangle have to add up to be greater than the third. I also know that 13 plus 9 need to be greater than n. And finally, I know 13 plus n needs to be greater than 9. Now, one of these you can X out, so use common sense. Find the one that's already true. Well, if I take 13 and add anything else to it that's a side, it's going to be bigger than 9. So I don't need to solve that one. But I do need to solve the others. Okay, so I'm going to minus 9. So n is greater than 4. And I'm going to add 23 plus 9. So 23 plus 9. 13 plus 9 would be 22. So 22 is greater than n. And now I'm going to switch this around and make it n is less than 22 and n is greater than 4. Now these are going to go together into a compound inequality for my final answer. I know that n needs to be greater than 4, but also less than 22. Okay, so that is the range of values that I can use. Now it says which of the following could be a side, could not be a side for n. All right, can my n be 7? Yes, that could work. Could my n be 13? Yes. Could my n be 10? Yes. Could it be 22? No, because it needs to be smaller than 22. So J is your answer. That's the one that you cannot use.